In this session, we will be looking at finding derivatives of certain functions using the power rule. If the function x exponent n, where n is any number, then the first derivative with respect to x, which is denoted by f prime of x, is given as nx exponent n minus 1, or dy dx is given as nx n exponent 1. All what we are going to do here is to bring the original exponent down in front of the function x and then subtract 1 from the original exponent. So you can see that the original exponent here is n, which is in blue ink, and then we will bring it in front of the function x here, and then after that we just subtract 1 from the original exponent. In order to use the power rule, you must note n must be a number and the x must be a variable. Now let's take examples and see how best you can apply this rule. Find the derivatives of the following functions. So you have the first one, the function of x exponent 6. So we know that the derivative is given as f prime at x, and then what we are going to do is to bring the original exponent, which is 6, in front of the function x, and then we subtract 1 from the exponent. So we are going to have this is coming forward. So we have the original exponent 6 is coming forward. So we are going to get 6, and then the function x, and then we have the original exponent. We are going to subtract 1 from it, and this is going to give us 6x power 5. So we can see that the derivative f prime at x is equal to 6x exponent 5. Now the second example, we have 4x exponent 3. So using the same method, we are going to have, which implies our f prime at x is going to be 4, and then the original exponent will come and multiply the 4. So we are going to have times 3, and then x exponent, we have 3 minus 1, and this is going to give us 4 times 3, we have 12. X 3 minus 1, we are getting 2, and that is the derivative of the second example. Now the third example, we are having the function 1 over x. Now before we can solve this, unless we convert this fraction into an exponential form or an index form, so in doing that, we know that we know that 1 over x can be written in an index form, which is x exponent negative 1. So now our function becomes f at x is equal to x exponent negative 1. Now that we are having a power, we can apply the power rule. So we are going to have the negative 1 will come and multiply the function in front, and then we subtract 1 from the power. So we are going to get minus 1. So at the end, we are going to get minus 1, and then we have the function x, and then we have minus 1 minus 1, we are getting what? Minus 2. Good. F prime at x is given as minus x exponent negative 2. This is the same as negative 1 over x exponent 2, and this is the derivative of the function 1 over x. Let's take the next example. So we have f at x is equal to the root of x. The root of x. We have to find the derivative of this function. Now before we can find the derivative of root of x, we have to first convert the root sign or the radical sign into what we call a fractional exponent in order to use the power rule. So in doing so, we can write our function f at x to be in a form of x exponent 1 over 2, because we know that root sign is the same as what? 1 over 2. Now that we have the power here, we can apply the power rule, which says that the original exponent has to come forward, and then we subtract 1 from the original exponent. So our derivative is going to give us, we have half will come in front, so we are going to get 1 over 2, which is the original exponent. We have our x, and then half minus 1. So at the end, we are going to get the derivative f at x is going to give us 1 over 2 x exponent half minus 1 will give us what? Minus half. Good. And this is the derivative, but we can just simplify it to make it look nicer. So we can say that the derivative f at x is going to be 1 all over 2 x exponent half, and this can be simplified to give us 1 over 2 root of x, and this is the derivative of the function root of x. Let's take the next example. Now we have the function f at x is equal to 1 over 3 bracket close cube root of x cube. Now before we can find the derivative of this, we have to change the cube root of x cube so that we can get something in the form of power, and then we apply the power rule. So we can write the function f at x, which is equal to 1 out of 3, and then we know that cube root is the same as what? 1 over 3. Square root is 1 over 2, cube root 1 over 3, fourth root 1 over 4. So you can write this as x exponent 3 all raised to the power 1 over 3, and 1 over 3 is the cube root. So from here we can see that these 3 will cancel this 3. So at the end, our function is going to be in a form of f at x is equal to 1 out of 3x. So now this is our function, and before we can solve it, we have to write this in an index form. So we are going to get 1 out of 3 and then x exponent negative 1, because we know that x exponent negative 1 is the same as 1 over x. Good. Now that we have the function f at x, which is equal to 1 over 3 x exponent negative 1, we can apply the power rule. So the original exponent, which is negative 1, will have to come and multiply 1 over 3, and then we subtract 1 from the original exponent. So at the end, we are going to get the derivative, which is f prime at x, is going to be minus 1 times 1 over 3, and then x minus 1 minus 1, we are getting minus 2. So let's simplify it small. Minus 1 times 1 over 3, we are getting minus 1 out of 3, and then we have x exponent negative 2. Now we can also simplify this to make it look nicer. So we are going to get 1 out of 3, and then x exponent negative 2 can be written as what? X squared. And this is the derivative of this very function. If f at x is equal to 2 over cube root of x exponent 7, we have to find the derivative f prime at x. That is the first derivative. So we know that before we can solve this, we have to convert this into an index form. Okay, so this is how we are going to get our function to be. So we know that f at x is going to be 2 all over x exponent 7, and we know that cube root is the same as what? 1 out of 3. So we are going to get 2 out of x exponent 7 over 3. Therefore, our function now is giving us 2 out of x exponent 7 over 3. Now, before we can solve this, we have to convert this one into an index form, okay, before we can apply the power rule. So we can write or rewrite this function in the form of 2x exponent negative 7 over 3. From here, we can apply the power rule. So we know that the first derivative f prime at x is going to be the original exponent coming forward, which is minus 7 over 3 times 2, and then x exponent negative 7 over 3 minus 1. And we know that negative 7 over 3 times 2 is giving us negative 14 over 3. Then we have x exponent negative 7 over 3 minus 1. We are getting negative 10 over 3. You can rewrite this in the form of negative 14 over 3 all over x exponent 10 over 3. And this is the derivative of the function written here. So we have the function f at x is equal to 1 over x exponent negative 2. Now we know that 1 over x can be written as x exponent negative 1. 1 over x negative 1 will be what? X exponent negative negative 1. And that is going to be what? X. So we can apply this concept here in solving this very question. So we can write our function f at x, which is 1 over x exponent negative x, in a form x exponent negative negative 2. And this is going to give us x exponent 2. Now our function is x exponent negative 2. So we can apply the power rule. So our derivative f prime at x is going to be the power will have to come in front. That's the original power have to come here. So we are going to get 2 and then x 2, and then we subtract 1 from the exponent. So at the end we are going to get 2x exponent 1, which is the same as what? 2x. And this is the derivative of this very function. Thanks for watching.